Welcome back to Easy Gates Instrumentation Gate 22 paper solutions. The next one, very interesting one based on a simple Wheatstone bridge, a DC bridge. It's almost connected to the sensors as well. So playing with the change in resistance and looking for the change in voltage at the output terminal of the bridge. Okay, so with that fundamental, we can still connect. So let me get into the problem. So we have a simple Wheatstone bridge consisting of three 1 kilo ohm resistors, one 1.5 kilo ohm resistors. So let us take the point where we need to play. Then we can play comfortably. Yes, what is given is this is R2 given 1 kilo ohm, R3 given 1 kilo ohm, R4 is given 1 kilo ohm, R1 alone is 1.5 kilo ohm. So 1K, 1K, 1K given. Okay, then a 30 kilo ohm resistance is given. So when closing the switch at time t equal to 0, the resistance, okay, before that, if the switch is initially open and the voltage between the points C and D is VCD. Okay, that means, okay, first the switch is open means R1 has only, the net resistance in R1 arm is only 1.5K. So when the switch closes, 1.5K will become parallel with 30K. Definitely the resistance will decrease. So it is going to resemble a situation of R minus delta R. That will result in some change in the output of the bridge. That's how the problem is playing with. Okay, so then the problem is what it is connecting means when closing the switch at time t equal to 0, resistance in the arm AD changes by, okay, exactly, that's a point. AD is the arm, the net resistance R1. So it is given as delta R1. I took it as delta R. Fine. Then the voltage between C and D changes by delta VCD. There is a change. Yes, already taken correctly. Then sensitivity of the bridge in volt per kilo ohm. So that means if delta R is in kilo ohms, if delta R is in kilo ohm, how much change in VCD will happen? That is going to be in voltage. So delta R should be taken into kilo ohm and VCD should be taken into what? Voltage. So that's a sensitivity, simply sensitivity VCD versus change in resistance. That's what we need to find out. So it may be positive or negative. So given VCD, so I have to take the C point positive, D point negative. Okay, as per the convention. Now let us play for the first condition. The first condition is, so t less than 0. T less than 0, switch is open. So this is only 1.5 kilo ohm. This is 1 kilo ohm. This is 1 kilo ohm. This is also 1 kilo ohm. So then let me take the bottom rail as a reference. So this is 0 volt. The top potential will be 10 volt and this point will be 10 volt. Then the 10 volt, it's a potential divider. So 10 volt will share across 1K, 1K. So the point C will be at 5 volts. Then what is the point D potential? So VD will be by potential division. Let me go with. Otherwise, straight away I can go for the current. It is 10 by 2.5K. If that is the case, it is going to be 4 milliamps. So 4 milliamps will make 6 volt drop. That means the point D will be at 4 volt. So VD will be straight away 4 volt. So then what is the VCD as of now? VCD is equal to, it is 5 minus 4. So aptly given. So it's C to D only. So that's output of the bridge. That is 1 volt. So as of now, the bridge is not in balance. So when there is no change in resistance, now delta R is equal to 0. If you connect your switch, there is going to be a change in resistance. Then how much change is going to happen in the VCD? That is what going to make the sensitivity. Okay. So now, as of now, the VCD, the output of the bridge is 1 volt. The bridge is not in balance. That's a point. Now the problem begins for t greater than or equal to 0. Now the switch is closed and 30K is in parallel with 1.5 kilo ohms. So this is still 1K. This is still 1K. That means point C is still at 5 volt as determined earlier. So we need to find out only the point D potential. Okay. So what is the point D potential? For that, we need to find out once again the potential at the point D. Okay. So yes, once again, we have to play for the current and then find the point potential D. So what is that? R1 parallel 30K. That is 1.5 parallel 30 is nothing but both are in kilo ohms. So it is going to be 1.5 into 30 divided by 31.5. Result is going to be in kilo ohms. So as a result, it is going to be 45 by 31.5 kilo ohm. Okay, that's your resistance. So let me go by potential division straight away. So VD is equal to 10 volt divided by this resistance 45 by 31.5 kilo plus the R3, that is equal to 1K and it is a voltage across R3. So this is your VD. Okay. So plus 1K. So into 1K will be the potential VD. Let me evaluate. We'll see what is the VD. Accordingly, we'll determine the solution. So then it is going to be something like So kilo and kilo will get cancelled. It is going to be 10 volt divided by, it is going to be 45 plus 31.5. So otherwise, straight away it is going to become, the remaining factor is going to become 45 by 31.5. It is going to be slightly more than 1, that is added with 1. So then 1 by something more than 2 you will get. So that is coming as 1 minute. So a small mistake, I guess. It is going to be 45 divided by 30, 1.5, that is equal to 1.428. So plus 1k. So plus 1, okay, plus 1. Okay, so that is 2.428. I'm getting kilo ohm in the denominator. So take the inverse. That is going to become 0.41176. I'm getting. Okay, that's a number into 10. Okay, so what is the VD? So VD is equal to into 10 means 4.11765 volt. I'm getting VD. Okay, so assuming the manipulation is correct, let me proceed further. So VD is this. So what's a new VCD means? The new VCD is equal to, okay, this is the VD. So otherwise you can play logically. So your VC remains 5 volt and VD actually increasing from 4 to this much. That means it is going from 4 to 4.11765. Okay, so whatever the voltage increases in VD, and VCD is nothing but VC minus VD. Since VD increases, so VCD should decrease by the same component. That means change in VCD is going to be negative. So VCD decreases by how much means minus. So it is going to be earlier 5. So 0.11765 is the decrease in your VCD. So that is negative. Definitely the sensitivity will be negative. VCD decreases. So out of what resistance means? So what is the resistance we need to calculate? It is 45 divided by the new resistance in R1 ohms. So 45 by 31.5. Okay, is the resistance that is going to be 1.42857 kilo ohm. That means what are the change in resistance? So change in resistance is also going to be negative. So therefore delta R decreasing from 1.5 to this much. So what is a fall means? It is 1.5. So minus 1.5. Let me do. It is going to be minus 0.0. It is already in kilo ohm. So minus 0.0714 kilo ohms. That is going to be in kilo ohm. That's a number in kilo ohm. So that's your delta R. It is falling and voltage is also falling. Straight away we can connect our sensitivity. Therefore, sensitivity is equal to change in VCD by change in resistance. So change in VCD negative, that is minus 0.11765 volts. The whole divided by delta R is also negative. That is minus 0.07143 kilo ohms. So therefore the answer must be, so the net answer will be positive. So it is positive, sensitivity is positive. Resistance decreases, voltage decreases. If resistance increases, voltage increases. Yes, that's correct. So it's positive. It is 1.6471 volt per kilo ohm is your sensitivity. So up to how many decimal places? Let's check. Up round off to 2 decimal places means then your answer. So some digits we discarded. Okay, we'll get very closer to that. So the answer must be plus 1.65 should be the answer volt per kilo ohm. Okay, hope this is the right answer. If any step mistake, you can suggest me for a change. Okay, so that's a way how the problem should go. Okay, simply go for change in VCD, change in go for go for change in resistance, and both are negative. Therefore, sensitivity will be a positive parameter. And hope you enjoyed this content, and do subscribe our channel. We'll update you with the next problem. Thank you.